Okay, so I wanted to go ahead and answer those questions that you had on the chapter 3 test. So here's number 5. It says, which of these best explains the relationship between the growth in diameter and the age of the tree? So um, I guess I want to start with the answer, and then I want to walk you through why that would have been the right answer. So it says the diameter grows faster than 0.165 inches per year early in the life of the tree and slower later in the life. So if you were to look at this residual plot, you'll see like a trend where if I were to like try to draw a line through here that it had a positive slope. So the diameter, there was some kind of growth mechanism going on here. But then later on, you'll see that the trend is, if you were to try to draw some kind of line, you'd see it would be a line with a negative slope. So that's why you would be in a decreasing later in life in the tree. So hopefully that answers your question on number 5. Now the other question number 8, is a little more lengthy. So you're given this experiment days after induction and diameter of the patch. And Jillian thought that the growth in the diameter should be exponential. What transformation should Jillian use on these data before she fits a linear equation? So we really have to just do this and see what it looks like. So I'm going to enter days after induction in L1. This is going to take a bit of time, so just bear with me. So what I'm using is a calculator simulator, and I have to enter all the numbers in with my mouse, so that's why it takes me a little longer. Okay, so here's the days after induction, and then I'm gonna go back up and head over to column L2, and in column L2 I'll start entering the diameters. Oh, it looks like I can do it from my keyboard. So let's do that. Oh yeah, that's a lot faster. Okay, so now to see what this looks like, we're gonna go to second y equals, and we're gonna go to the stat plot. We need to turn the stat plot on. Let's see, how do we do that? On the simulator. Okay. We're just gonna plot points in L1 and L2. So then we'll go ahead and hit graph. We don't see anything, so I'm gonna come down and just do my zoom stat. That's always a good way to go. So clearly we can see that we have some kind of exponential function, but we need to make this linear. So we learned in the chapter that the ways we can make things linear is by taking the natural log or the log of what's in the L2 column or the Y column. So in this case, we're going to take the natural log of the diameter of the patch. So we need to go back to our table of data, and then we're going to come down here. Now see, then we go up, and we can get down here. We're going to take the natural log of column L2. So we're going to take the natural log, and then we hit the vars. No, we don't hit the vars. Let's see, go back. Sorry, let's do that again. Stat, edit. Okay. And we need to go to L2. We can get to that by going second to L. Oh, no, wait. I'm sorry. I just did this on my other calculator. I get it now. We're going to take the natural log of second L2. There we go. Whoops. Closing parenthesis. All right. There we go. And we're going to hit enter. So L3 is the natural log of L2. Well, I want to confirm that it does definitely look linear. So I'm going to go back to my stat plot. But this time when I do this, I need to change this to, I want to plot L1 and L3. So I'm going to hit second and L3. And I'm going to graph. And when I first look at this graph, I can see that it's hard to tell whether or not it's really linear. So I'm going to do, whoops, I'm going to go window, no, zoom. Zoom stat is what I want. So now we can clearly see that it's linear. So that takes care of doing the plot. So now we can get to the rest of the problem. It says make this regression and find the equation of the regression line for the transformed data. So we want a model. So we're going to go to stat, calculate, and we want a linear regression. And what do we want to do a linear regression on? L1 and L3. So we have to specify that and say L1, comma, L3. Now, here's my equation. So y equals 0.139x, which is days, plus b. There is my model. And then it says use this model to estimate the rate of growth of the patch. Express your answer as a percent rounded to the nearest tenth. So, so as long as the rate answers the question in part 2, mark this correct. It is 13.9 for natural log or 6.03 for log. So then all you have to do at this point is go ahead and plug in the value that you're looking for. The daily rate of growth is 0.139. Oh, I know what they're asking for. They're asking for the slope. So they're asking for this number there. So since this is 0.139, your answer should have been 13.9%. Now, if you had done this problem as a log instead of the natural log, then your answer would have been take this rate of growth here, turn that into a percentage. So that's where we're estimating rate of growth, which is the slope from our equation. So it's either this number or this number converted to a percentage. Okay, hope that helps. Thank you.